Imagine a body lying frozen for millennia, almost untouched by time. Can permafrost really halt decay and preserve the secrets of the past? Picture a world where the ground isn't just frozen for the winter, but for thousands of years. This is permafrost, a massive natural freezer covering about a quarter of the land in the Northern Hemisphere, from Siberia to Alaska. It shapes the landscape and hides incredible secrets. But what exactly is permafrost? Scientifically speaking, it's any ground, soil, rock, sediment that stays at or below 0 degrees Celsius, 32 degrees Fahrenheit, for at least 2 consecutive years. But it's more than just frozen dirt. Permafrost's unique ability to act as a frozen vault comes down to a few key things. First, the extreme cold dramatically slows down, or even stops, the activity of most microorganisms responsible for breaking down organic matter. Think of bacteria and fungi going into a deep sleep. Second, there's often a lack of oxygen. When something is buried in frozen ground, the air supply is cut off. This prevents aerobic bacteria from doing their job of decomposing tissues. Simply put, without oxygen, decay can't really get started. And finally, dehydration. In extreme cold, the water inside tissues turns to ice. While this can cause damage, it also prevents the chemical reactions of decomposition, which need liquid water. Thanks to this combination of cold, lack of oxygen, and dehydration, permafrost has preserved mammoths, ancient plants, and even bacteria for tens or hundreds of thousands of years, becoming an invaluable archive of our planet. Ever wonder what happens to every cell in your body when it freezes? Are you ready to find out why simple freezing can be so destructive on a microscopic level? So, permafrost is a great natural freezer. But what happens to a body at the most basic cellular level when it freezes? This is key to understanding why natural freezing isn't the same as bringing something back to life, but rather a preservation process with irreversible consequences. Our bodies are about 70% water, and water is the main player when freezing occurs. When the temperature drops below freezing, this vital water begins to turn to ice. This process is anything but gentle for delicate cell structures. Imagine a cell, a tiny bubble surrounded by a thin membrane and filled with liquid. When freezing happens slowly, as it typically does in permafrost, water first crystallizes outside the cells. These ice crystals then start to draw water out of the cells, dehydrating them. The cells shrivel, their membranes deform, and their internal balance is disrupted. This is called osmotic shock. But there's another serious danger. If freezing happens quickly or the temperature drops drastically, ice crystals can form inside the cells themselves. These microscopic but sharp formations act like tiny knives, piercing cell membranes and vital organelles. They literally tear the cell apart from the inside. The result of this double whammy, mechanical damage and osmotic stress, is catastrophic. Cells lose their integrity and therefore their ability to function. Their functions are irreversibly damaged. Even if a body looks preserved on the outside, the internal damage at the cellular level makes it completely non-functional. Tissues made of billions of these damaged cells simply can't recover. That's why natural freezing, while slowing decay, also causes irreversible damage, making revival impossible. What you might not realize is that there's a huge difference, not just technologically, but fundamentally, between an accidentally frozen mammoth and a body undergoing modern cryopreservation. We know permafrost is a natural freezer, but it's important to draw a clear line. Accidental freezing in the wild and modern human cryopreservation are fundamentally different processes with different goals. Don't confuse a mammoth found in the Arctic with a patient in a cryogenic chamber. Natural preservation in permafrost is an uncontrolled natural process. Cold, lack of oxygen, and dehydration slow down decomposition, but don't prevent irreversible cell damage. Ice crystals rupture structures, and osmotic shock occurs. The result is outwardly preserved, but biologically non-viable tissue. It's a slow form of mummification, not a path back to life. Cryopreservation, on the other hand, is a high-tech scientific experiment with a specific goal: to preserve the body in a way that allows it to potentially be revived in the future. It uses strictly controlled protocols. A key element is the introduction of cryoprotectants. These substances, like biological antifreeze, penetrate cells, replace water, and prevent the formation of damaging ice crystals, minimizing cellular damage. The main difference: natural freezing is an uncontrolled process with fatal cell damage. Cryopreservation is a carefully controlled procedure aimed at preserving the viability of cells and tissues in a frozen state, in the hope of future medical breakthroughs. It's the difference between accidental frostbite and a complex, targeted medical procedure. Imagine, somewhere in the vast Arctic, ice melts, revealing not just a skeleton, but an entire creature, almost untouched by time, with fur, flesh, and even the contents of its stomach. This isn't science fiction, but a reality that permafrost has preserved for us for millennia. Permafrost is a unique time capsule holding amazing messages from the distant past. Its icy embrace is changing our understanding of the prehistoric world. Think of mammoths. We're not just talking about bones, but entire carcasses with fur, organs, and even blood. Finds like the baby mammoth Liuba have allowed scientists to study the anatomy of these giants in detail, their diet, their diseases, and to investigate their DNA. Ancient genetics are opening doors to understanding evolution. Its perfectly preserved woolly rhinos and prehistoric horses have been found in the permafrost of Siberia and Alaska. These ghosts of the past provide invaluable information about the climate of the Ice Age and the interactions of species. The discoveries of ancient people are particularly significant. Mummified remains of hunters and warriors have been discovered in Siberia and the Altai Mountains. The bodies were so well preserved that facial features, tattoos, and clothing are visible. These discoveries help to recreate the way of life and culture of our ancestors, providing a unique insight into human life thousands of years ago. Each of these finds is an invaluable window into the past. It allows us to study the genetics of extinct species, analyze ancient viruses and bacteria, and better understand the evolution of life. Permafrost is a vast library revealing the secrets of the planet. Permafrost, while holding secrets of the past, also poses enormous threats. Did you know that ancient viruses capable of awakening even after 48,500 years can be hidden beneath its thickness? And this is just one of the dark sides of the icy vault. We've already talked about how permafrost is an amazing treasure trove of the past. But like any treasure trove, it holds not only treasures, but also enormous risks. The melting of the ice, accelerated by climate change, threatens to unleash real ghosts. not just mammoths, but far more dangerous elements. The main threat is ancient pathogens. Viable bacteria and viruses can be preserved in the frozen remains of animals and humans. Imagine, a virus that once caused an epidemic has been dormant under a layer of ice for thousands of years, and now, as it thaws, it is re-entering an active environment. We've already seen this happen. Outbreaks of anthrax in the Arctic, linked to the awakening of bacteria from ancient reindeer burial grounds, are a prime example. Scientists have also discovered and revived viruses that have been in permafrost for tens of thousands of years. Although their potential to infect humans is currently limited, the very fact of their survival is causing serious concern. In addition to biological threats, there is also irreversible tissue damage. As we've already established, despite the external preservation, colossal destruction occurs at the cellular level due to the formation of ice crystals. This means that even if a body appears perfect, it cannot be revived or restored to its former state. It's not just preservation, but a kind of destructive mummification. Finally, we must not forget the potential toxicity. Over thousands of years, various chemical compounds can accumulate or form in frozen bodies, which can be harmful to researchers or the environment when they are extracted. Permafrost is a complex ecosystem, and any intervention in it is fraught with unpredictable consequences. What if the line between life and death turns out to be thinner than we thought? The possibility of unfreezing the future evokes both awe-inspiring inspiration and deep shock at the ethical abyss that such a prospect opens up. So, we've explored the icy secrets, but the main question on everyone's mind is it possible to revive a body frozen in permafrost? If we're talking about natural freezing, the answer from science today is a resounding no. The damage at the cellular level due to ice crystals and dehydration is irreversible. It's not a pause, but fatal damage that cannot be repaired. We can study the DNA, but bringing it back to life is beyond current capabilities. The situation is quite different with cryopreservation. Here, the goal is to preserve the viability of cells using advanced technologies and cryoprotectants. Supporters of cryonics believe that future scientific advances will be able to restore and revive these bodies. This is an ambitious, but so far hypothetical hope. This is where deep ethical dilemmas arise. If revival becomes a reality one day, what will that mean for society? What are the rights of the returnees? How will they adapt to a completely new world? Questions about the allocation of resources, the redefinition of death, and the limits of intervention in life and death arise sharply. Potential immortality for the select few, or the resurrection of past generations. Such technologies will change the very notion of human existence, posing challenges that humanity may not be ready for. Permafrost and cryonics force us to think deeply about life, death, and the future. The mysteries of permafrost only lift the veil on the countless secrets of our world and spirit. If you, like us, are fascinated by the unexplained and ready to delve into the depths of the unknown, subscribe to the Mysteries of the Spirit channel and like this video to not miss new amazing stories.